Hello everyone and welcome to my channel Maths with Lazy Bee. In this video, we'll be discussing a question of JEE Advanced 2024. So the question is of matrices and determinants. The question says that you have an equation x squared plus x minus 1, which is a quadratic equation, and alpha and beta are the two distinct roots of this equation. Okay, so first let us know the values of alpha and beta. Since this is a quadratic equation, we can easily use the formula and find out the roots. This is going to be this. So the roots are -1 plus or and minus of this. So this is alpha, this is beta, or this is beta, this is alpha, doesn't matter. So these are the roots. Okay. So alpha and beta are this. And we have a set T, which is 1 alpha and beta. We have a matrix Aij, and they have defined some things. So they're saying that if this is the matrix A11, A12, A13, A21, A22, A23, A31, A32, and A33. So they have defined R1 as the sum of the elements present in the first row. This is the first row, this is the second row, and this is the third row. So R1 is the sum of the elements of the matrix of the first row. So A11 plus A12 plus A13. Similarly, R2 is the sum of the elements of the matrix in the second row. This is A21 plus A22 plus A23. And similarly, for the third row, they have defined R3, sum of the elements A31 plus A32 plus A33. And they have defined CJs as sum of the elements present in the first column is C1, sum of the elements present in the second column is C2, and for the third column it's C3. So C1, for example, is A11 plus A21 plus A31 because all these elements are present in the first column, just the rows are varying. So this is what they have defined in the question. Okay. Now we'll be solving the question, and this is a match the following question. So for part P, they're saying that find the number of matrices with all the entries in T, and this has to be a 3x3 matrix. So I have to find the number of such matrices which have the entries from the set T and also satisfy this condition that for all I and j are I equals to Cj equals to 0. That means R1 equals to R2 equals to R3 equals to 0, as well as C1 equals to C2 equals to C3 equals to 0. So we have to find the number of such matrices. Okay. So now, and also the condition is that the entries should be taken from the set T. This T. Okay. So T is 1 alpha and beta. And this is the matrix A11, A12, A13, A21, A22, A23, A31, A32, and A33. Okay. So if you find the total number of matrices with entries from T, what answer are you going to get? This has three choices. Similarly, this has three choices because the cardinality or the number of elements in T is 3 here. So this has 3 and all the entries have 3. So this is just going to give you, since there are 9 entries, so this is going to give you 3 to the power 9. But we just don't need to find the number of elements, but we have a condition which has to be satisfied by those matrices. So the condition is that all the rows and columns should satisfy this for all I and for all j. And the entries should be from this set T. Okay, so we see how many choices do we have. But first of all, that means since the entries should be from T and Ri and Cj should be 0 for all I and j, so how are the elements of T going to will be satisfying this condition? How will they be satisfying this condition? So we need to see. So if I think of repeating elements in a row or in a column, for example, you know that alpha and beta are given by minus this. These are the values of alpha and beta, and the row, for example, if I consider the first row, then can I keep this as the first row or as the first column? Is it possible? So according to the condition, the sum should be 0. So that means 3 alpha equals to 0. So this is not possible because this means that alpha needs to be 0. And this is not the case. Alpha is not 0. Alpha is this, either plus or minus, minus 1 plus root 5 by 2 or minus 1 minus root 5 by 2. In both the cases, alpha is not 0. Similarly, I can't keep the first row having the elements as beta, beta, beta. I can't keep this in any row or any column because ultimately I'll be getting beta as 0. Because 3 alpha equals to 0 or 3 beta equals to 0 gives me, because I take the sum, I am considering the sum because it is the condition. I have to fulfill this condition that all the columns and all the rows have to satisfy this. That means whether I choose any column or any row, and I add the entries in that particular column or row, I should be getting a 0. So if you put for any column or any row, you take all the entries at alpha, 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 beta, 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 you're not getting a 0 because 3 alpha equals to 0. That means alpha is 0 because 3 is not 0. So similarly, if you are thinking of keeping 1, 1, 1, this is also not a good idea. Or it is not going to work either because 3 is not equal to 0. We'll be getting 3 as the sum and it is not 0. That means we cannot repeat these entries. Can't keep them 3 times. But can we make it like this? Alpha, alpha, or 1? Is it possible? So again, their sum will be, for example, plus 1 equals to 0. This is going to give you alpha equals to minus 2, and alpha is not minus 2. It has this root 5 term also. Similarly, if you think of keeping it like this, it is also not possible. It is also not possible because 2 alpha plus beta is not 0. You add these terms and we won't be getting a 0. So the only possibility is that first add alpha beta, and since these are the roots of this equation, x square plus x minus 1, yes. So they'll be satisfying the sum of the roots property, that will be minus b upon a, which is minus 1. So that means the sum is minus 1. And if you add 1 to it, you'll be getting a 0. So this is the only possible choice. You can arrange the elements of T so that the sum in any row and any column is 0. So this is the only possibility. Okay. Because we have already ruled out the other possibilities, we were not getting the sum as 0. If we were getting alpha twice, if we were taking alpha twice or beta twice or 1 twice, then we were not getting a 0. And this is the only possibility. This is the only possibility. We can arrange the elements in our matrix. Okay. So let us now start choosing the elements. Now, so that means every column and every row should have this pattern. because every column and every row should be, if you add the elements of particular row or a particular column, you should be getting a 0. So you will be getting a 0 only if the elements are of this alpha, beta, 1, 1, beta, alpha, anything, but the pattern should be like this only. Okay. So if you, first of all, place it like this. Let this be alpha, this be beta, and this be 1. Okay. So what are the remaining choices? Now, these are the remaining elements to be, remaining positions to be filled now. So this row is giving us 0. If you add the elements, you'll be getting a 0. What about the first column? You need a 0 here also. So that means you can't take it alpha. If you choose this element, you can't keep it as alpha because this is like Sudoku game. Every element should come once, both in a row and in a column. So alpha should come once only. So this means that this can be either 1 or beta. So if you place it beta, let this be beta. So this will be 1 automatically because you have to make the sum 1. You can't keep any other element. So you'll have to make it 1 only. Okay, now since you have selected this was your choice. What about the other 4 positions? Okay, now this is beta and this is beta, and every row and every column should have, every element should appear just once in any row or any column. So this is beta, so I can't keep beta here. So what is the other option? So the other option is, so I have chosen these elements, but what about these 4 elements? Now, if I can't, very clearly I can't put alpha, I can't put beta here because beta is already present in this row. Okay, so I can't put beta here. So can I put alpha here? Can I put alpha here? But that is also a problem because if I put alpha here, then I'll have to put 1 in the last position here. But that is also a problem because 1 is already present in the third row. So that means here it is 1 and beta is already occurring in the second row. So I'll have to put alpha here. Alpha is here and this. So this was not a choice. This was a compulsion for me because beta was beta and 1 were deciding the position of this element, deciding the fate of this element. It could not be 1 because of this, and it could not be beta because of this, so it had to be alpha. Similarly, since an element appears only once, so beta is here, alpha is here, so the only choice here is 1. Now in the third row, 1 is here, alpha is here, so ultimately the choice is beta. Now beta is here in the third column, 1 is here, so put alpha. So how many elements could you choose? So let us repeat this exercise once more so that you can understand what was going on. So you make the matrix, you have to fill the 9 positions, 9 entries using this set such that an element appears only once. Either you count it in a row or in a column, it has to appear only once. Now if you have chosen something for the first row, if you have already made a choice, for example, this is the choice, and for this column also, you have made a choice. You will have to make these choices because then only you will be able to decide whether the 4 entries are depending on your choice or are governed by the elements of the first row and the first column. So first of all, you should always make a choice and then see whether which all other elements are dependent on your choices. So, and let us make this choice. This is also alpha and beta. Now, how to choose these elements? Okay. So, what I am saying that alpha is already here. So that means you can't put an other alpha here because alpha is in the second row also and the second column also. So alpha not possible for this part. Okay. Is 1 possible? Can I place 1 here? So if I place 1 here, then I'll have to place beta here. So that is also not possible because beta is already present in the third row. That means I am bound to place beta here and 1 here. Similarly, since so you didn't choose anything, this position, this element was decided by this and this alpha and this beta. You didn't choose anything. Similarly, its position, this one was decided by the column, by the second column. Since alpha and beta were already present, so one was the only choice. Now, this beta, this one is present in the third row, so alpha is the only choice for the last element, and alpha and beta are present in the third column. So 1 is the only choice because every element has to appear just once in any row, any column. So this was the only choice. So how many? So you notice that these 4 elements were not coming out of your choice. You had to place them because these elements were decided by your previous choices, the first row and the first column. And similarly, you can play this game by placing any by choosing any row or any column, you will be getting the same. Now, how many elements did you actually choose, or can you actually choose? So, can I choose this element? Of course, because we have 9 entries, and you can choose this one because you don't have anything else. No, nothing is breaking the restriction of the entries in rows, and should be the sum should be 0 and same for the column. So you are free to choose anything of your choice. But you have, how many choices do you have? 1 alpha beta. That means you have just 3 choices, and you have chosen 1 here. So this is just following the principle of counting. Now, if you place 1 in this box or in this circle, then you have only alpha and beta for the second one because 1 is already present and should appear only once. So alpha or beta. So how many choices you have? 2. And similarly, if you place alpha here, then you will be bound to place beta in the last uh, position. So you had 3 into 2. And if you, okay, but can you choose the entries for your first column right now? Yes, because you have 2 free entries right now. You place 1 here. So this has how many choices? 2. Only 2 choices. And if you place beta here, then it will always be alpha over here. So that means you could choose this also. But as I have already I have already shown you that these entries are decided by your previous choices. So that means in total you had only 3 into 2 into 2, 12 choices. So the answer for the P part is 12. So 12. This is for P. Now coming on to the Q part. Q part asks you the number of symmetric matrices with all the entries in T. So the entries are coming from the set T only. But here they have relaxed the condition somewhat. They are not asking for all R I equals to 0, but they are asking you that Cj should be 0. All Cj should be 0. So you have to find the number of symmetric matrices with entries in T such that Cj is equals to 0 for all j. Okay. Now solving this. So symmetric matrices. Symmetric matrices. So if you have this, diagonal entries are always free, but the symmetric matrix mean that this, sorry, A12 will be same as A21. This has to be same as this, and this has to be same as this, and this has to be same as this. So this is a symmetric matrix. Diagonal entries are free to choose, but if you choose this, then this is bound to be the same element as this. If you choose this, then this has to be same, and if you choose this, then this has to be the same. So this is the condition of symmetric matrix. Entries are again coming from the set T only. These are again coming from the set T only, and the condition is Cj should be 0. So that means you have to follow the same pattern that in every column, one alpha and beta should be there and should appear only once. Since there are 3 options and should appear only once, each should appear. So that means repeating is obviously not possible. Okay. So A11, A22, and A33. So let us see how many elements do we get this time. Now you are free to choose this. So let us choose this as 1. Okay. So let us decide for the first column, because the sum has to be 1 for all the columns. Sum has to be 0 for all the columns. So let it be alpha and let it be beta. Right now I'm not counting the elements. I'm telling you how these choices are going to affect my other choices. So this is 1 alpha and beta. Now this and this has to be same. This is going to be this, and A31 equals to A13, because this is a symmetric matrix. What is the condition of symmetric matrix? A transpose equals to A. A transpose has to be equals to A. This is symmetric matrix. Now this means beta has to be same as this. So once you chose the elements for your first column, your first row was automatically selected. And since your first column gave you the sum to be 0 and your entries are same in the first row also, so this also gives you R1 to be 0. So Cj to be 0 is giving you automatically Ri to be 0 because of the condition of symmetric matrix. Okay, now what about the other elements? Now, can you choose this one, this element? The A22. This is A22. Can you choose this one? So if this is alpha, can I put it beta? Can I put this beta? But since this is alpha, so I have 2 choices. I have to place, every entry should be unique now. So I have 2 options for this, 1 or beta. So if I keep this 1, then I'm bound to keep it beta to make the sum 0. But I can't keep it beta, because once I choose this to be beta, because I don't have any restriction on the row right now, it is fine. But once I keep this entry beta, I'll have to keep this beta, and for the third column, it doesn't become 0. Beta is appearing twice. So this will be a problem. So I can't keep this as 1. I am bound to keep this entry as beta, because once this is beta, this will be 1 and this will be 1. So this entry which has to be equal to this entry has to be 1, and this is alpha. So repeating this exercise once again, just once. So what did you observe? That once you choose the elements for your first column, for example, this is 1, this is alpha, and this is beta, and this is your choice. Okay, so the pink shows your choice. This has to be equal because of symmetric matrix. This has to be the same. So this is not your choice, not choice. This is bound to be like that. This is not your choice. It has to be because this is governing this. These two elements. These elements are governing these elements. Okay. Now what about the other 4 elements? Now, can you choose this element? So since this is alpha and every element has to appear just once for making the sum to be 0, so that means for this element you have 2 choices, either 1 or beta. But if you place 1 here, then what is the problem? That beta is coming here. Beta has to be there because the sum has to be 0. But this beta decides the fate of this element, this position. So this has to be beta, and this makes the sum to be not equal to 0, which is a problem. So that means I don't have a choice for the diagonal element. I am bound to keep it beta only, because this can't be 1, because if it is 1, then this is beta, so this is also beta, and we get 2 beta plus something, but this is ultimately not going to give us a 0. So this is beta, and to make this sum 1, we have to make this 1 sum 0. This has to be 1. This is 1, so this will also be 1. This is 1, and this is beta. To make the sum 0, it has to be alpha. So yellow denotes the foundation. It was a foundation. You were bound to make these elements work according to your choice, which is shown in the pink, which is shown using the pink color. So how many elements did you actually choose for yourself? So only this column for this column. So for this, you had 3 choices. For this, you had just 2 choices. And for this, you had 1 choice. So that means 6 elements. Or sorry, 6 choices. Or 6 ways. So how many matrices do you have? 6 such matrices. Because you could choose this. You could choose this alpha. If you had chosen this alpha, this should have been either 1 or beta. So that means 2 choices. And once you choose it to be beta, the last element, the very last element had to be 1. So this had just 1 choice. So total choices are 6. So this gives the answer for the part Q to be 6. This is Q. So that means for Q you have this option. So that means either B is the answer or C is the answer, depending on your answers for R and S. But S is also giving us 5. Now S is easy. Although B and C are deciding this for you, that in both the options you are getting S as 5. So how? So this is easy. S is saying that M is a matrix with all the entries in T again, such that Ri equals to 0. So that means if you keep this alpha and beta you have to keep because the entries are coming from the T and from the set T and the rows, so sum of the rows should be 0. So this has to be 1 alpha and beta. And in the second row also this should follow the entries, the order can change. The order can change. This can be beta 1 and alpha or alpha beta or 1, but the entry should be like this only, 1 alpha beta. So should come once. Every entry or every element of the set T should come once only, exactly once. So now you have to calculate the absolute value of the determinant of M. So this is M. And you are given, and according to your choice, you have that Ri equals to 0. You have to calculate the first the determinant and then take the modulus to get the absolute value. So one easy method is that you take one and the traditional method that you follow to find out the determinant. But if something is given to us, then that has to be used because that will be making our solution very much easy. So you have that Ri equals to 0 for all the I. So we have to use this. But how? So Ri equals to 0 for all I is nothing but 1 plus alpha plus beta equals to 0. So how is this going to help us? Now you know that if you are using column transformation or row transformation, that is not going to affect the value of your determinant. So you can use it freely. That means if you use this, you add these entries together. So for column 1, if you do this, C1 plus C2 plus C3, you'll be getting 1 plus alpha plus beta because all the entries appear. This is just an example of matrix. A real matrix also is going to look similar because all the entries appear once in a row. So if you take the sum, you will be getting 1 plus alpha plus beta. Similarly, in the second row also, you'll be getting 1 plus alpha plus beta. And in the third row, first entry, you will be getting the same thing again. So so that means this is 0, this is 0, this is 0, and this is anything, you don't know. But since the entries appear once in every row and exactly once, so if you take the sum, this, then the first column becomes 0. And when row or column is 0 in a matrix, then the determinant is nothing but 0. So this gives you 0. So the answer for S is 5, and you can check that.